In Chapter 6, we discuss a stronger notion of typicality of sequences called strong typicality. In Section 6.1, we discuss a stronger version of the AEP called the strong AEP. In this setup, we consider a random process x sub k greater than or equal to 1, where xk are IID with generic distribution P of x. Let x denotes the generic random variable with finite entropy. As before, we denote a random sequence by bold x. Then the probability of the x sequence is equal to probability of x1 times the probability of x2 all the way to probability of xn, because x1 up to xn are independent. Compared with the setup for weak typicality, we make the additional assumption that the alphabet is finite. Let the base of the logarithm be 2, that is, the entropy of x is in bits. Here are some notations. Consider a sequence of length n. Let n, x semicolon x sequence be the number of occurrences of a particular value x in the sequence x. Dividing it by n, we obtain the relative frequency of the value x in the sequence x. The collection of relative frequency of x over all x is called the empirical distribution of the sequence x. As an example, consider the length 5 sequence consists of the values 1, 3, 2, 1, and 1. Then the number of occurrences of 1 is equal to 3, the number of occurrences of 2 is equal to 1, and the number of occurrences of 3 is equal to 1. The empirical distribution of this sequence x is equal to 3 over 5, 1 over 5, and 1 over 5. In the strongly typical set to be defined, there are two parameters, n, a positive integer, and delta, a small positive quantity. The strongly typical set T sub x delta sub n with respect to the generic distribution Px is the set of sequences of length n such that the number of occurrences of x is equal to 0 for all x not in the support, and summation x, the absolute value of the relative frequency of x minus the probability of x, is less than or equal to delta. The sequences in a typical set are called strongly delta typical sequences. Note that in the above definition, if the summation is small, then so is every term in the summation. That is, the absolute difference between the relative frequency of x and the probability of x is small for every x in the alphabet. In other words, the relative frequency of x is very close to the probability of x for all x. Therefore, if x is strongly typical, the empirical distribution of x is approximately equal to the generic distribution Px. Further, if x is strongly typical, then the probability of xk is strictly positive for all k, because in equation 1, it is required that for any x not in the support, it cannot occur in the sequence.